Shown here is the spike glycoprotein of the coronavirus. To orient the picture, this area here would be the virus capsule, and down at the end in orange is the receptor binding domain that will attach to a cell. These binding domains are currently in the closed conformation, and as we can see in the right picture, there are 3 separate binding domains. As the virus is inside a body and preparing to attach to a cell, one of the receptor binding domains will hinge open, and this will allow for better attachment to the receptor. The receptor that the coronavirus attaches to is the angiotensin converting enzyme 2, or ACE2, as shown here. This enzyme sits within the plasma membrane of the cell. When looking at the image, we can imagine the plasma membrane extending on either side. This means that this side is extracellular, where the virus will attach, and this side faces the inside of the cell. This is what the spike glycoprotein looks like as it is attached to one ACE2. Once one ACE2 is bound to the spike protein, a second receptor binding domain will open and attach to an ACE2, followed by a third. This image shows the spike protein fully bound to the cell membrane via ACE2. We can see that the receptor binding domains are all in the open conformation. The glycoprotein attaches to 3 ACE2 to form crosslinks. As shown here, we can see how tightly the receptor binding domain is to the ACE2. The close proximity tells us that they are tightly bound together. These final images show the same bonds with different representations. The image on the left shows the backbone of the spike protein and the ACE2. Then the image on the right shows the secondary structures in color and a translucent shell to depict how much space the molecules take up.